We want to continue our look at reviewing techniques of integration, and today we want to look at integration by substitution. So yesterday we looked at integration with just using our fundamental theorem of calculus, and today we're going to need to use our integration by substitution, which you remember is we want to find our u and our du as we do these techniques. So if you remember doing our integration of substitution, the things we are looking for is we are looking for an inside function or an inside part that is our u, and then outside of that function you want to see the derivative or the du. So in this one we're going to make our u 1 plus x squared, and so our du is 2x dx. Now I don't have a 2x, but all I need is a 2, so I'm able to put a number in here. We can't put a variable in there. I can put a 2 there, then I need to put a 1/2 out in front because those cancel, and so I haven't really changed anything. So then my new integral becomes 1/2 the integral, my 2x and my dx become my du, and my 1 plus x squared becomes my u, so I just get the integral of the square root of u. Now, just as when we've done derivatives in the past, anytime we want to take an antiderivative of a radical, I want to change it to an exponent. So I have my 1/2 out in front, and I'm going to take the antiderivative of u to the 1/2. And remember, when we take the antiderivative, we add 1. So 1 plus 1/2 is 3/2. I then need to put a 2/3 or divide by 3/2 out in front, so that when I take the derivative and bring down a 3/2, that cancels since there's nothing in front here. Then we have our plus c. So if I multiply here, these would cancel, and I would get 1/3 u to the 3/2 plus c. And then to get my final answer, I'm going to substitute my u back in, which is 1 plus x squared to the 3/2 plus c. So that is solving an integral by using substitution, by figuring out what to make my u. Try another one. The integral of e to the x divided by 1 plus e to the x. Now, one of the things to remember when we make our u can never be, our du, excuse me, can never be on the bottom. So if I made my u e to the x, my du would be the other e to the x on the bottom. So in this case, my u has to be 1 plus e to the x. So then my du is e to the x dx. So this top is my du. This bottom is my u. So once I substitute in these two things, my new integral becomes 1 over u times du. So the antiderivative of 1 over u is natural log. Remember, whenever we do the antiderivative and end up with natural log, we always want absolute values around the u. So this, then I can substitute my u back in, gives me the natural log of 1 plus e to the x with my absolute value signs there, plus c. Now, the last thing we want to look at is what happens if we have an integral with our limits that we have to do substitution. Now, I'm going to do this the first time kind of with the way that, if you remember, the way that we like to do it. And that is, I'll make my u x cubed. My du is 3x squared dx. So this simplifies to the integral of, here is my du. So this is just e to the u du. And the antiderivative of e to the u is just e to the u. And I substitute my u back in, which is x cubed. I put in my 0 to 2. So I get e to the 2 cubed minus e to the 0 cubed, which is e to the 8th, and then e to the 0 is 1. So I get e to the 8th minus 1, which if I put that into a calculator, I will get 2979.958. So there is my answer. Now, if you remember, the other way you could do this problem, which would be to do my u the same way, x cubed. My du is the same, 3x squared dx. And then I change my integral, just like before, to e to the u du. But the difference now is I use this u. So if u is x cubed, u, when I plug in 0, gives me 0 cubed. So that's my bottom limit. My u, when I plug in 2 for x, gives me 8. So that is now my top limit. And I have changed my limits of integration. So I forget everything I've done before. And now I just look at this. And the antiderivative of e to the u is e to the u. My new limits are 0 to 8. So I get e to the 8th minus e to the 0, which is e to the 8th minus 1, which I get the exact same answer I got before, 2979.958. And so you can see both of these ways give me the same answer, just kind of different ways of getting that answer. If you remember, usually when I'm going to do this problem, I'm going to do it this way, where I just substitute my u back in, and then I plug in my original limits. However, this is also a mathematical way you could do it, where you completely change your limits and get your answer. All right, we are now ready for the homework over the review of integration by substitution.